Okay. Oops, sorry. That was the wrong slide. Wish it was over already, but okay. Good afternoon. Thank you for joining us this afternoon. Welcome to the e-learning session on solving problems with Guess and Check. Again, my name is Helen Chan, and I will be your moderator this afternoon, along with Mark Goldstein, and hopefully Joe Packham will be joining us shortly. So for the next 30 minutes, we'll be reviewing lessons 26.2 and 28.2 from the Introduction to Algebra program. We will be presenting a series of 3 live sessions this afternoon. This is actually the last group of live sessions for the semester. So hopefully you can join us for all 3 sessions. But if you're not able to, then just know that these will all be recorded and archived, so you can watch them at a later time. All you have to do is go to the e-learning page on our website and click on the Watch Session button of the session that you want to access. Okay. If you are watching this as a pre-recorded session and need to contact us for any assistance, please feel free to email one of us, and we'll be happy to answer your questions. If you missed jotting down our email addresses, don't worry, we'll put up our contact information again at the end of this session. Okay, so what I had to do just before we started was checking checking each other's answers. So were there any ones that you found that were incorrect, or were they pretty much, it looks like number 3 was checked, number 2 was also checked, and number 5. So unless there are any objections, we're going to move on to the lesson. No objections? Okay, let's move on. Okay, so here are the goals for lessons 26.2 and 28.2. These 2 lessons come near the middle of the symbolic algebra cluster in our program. In the earlier weeks, students distinguished between expressions and equations. They also practiced writing and evaluating expressions using order of operations, and they also developed strategies for solving simple equations. Later on, in later sessions, students will learn how to manipulate and solve more complex linear equations and apply their equation solving skills to other contexts. So, and throughout this lesson, we'll also continue to see elements of the fourfold way, just so that you know. In case you are a first-time Introduction to Algebra teacher user, I'd like to point out that there are other word problem lessons in the program, but we're only focusing on the perimeter and train problems this afternoon because those tend to be more challenging for students. You can see that, let me get my pointer here. You can see that these actually span over 3 weeks. And here, this last one right here, the first 3 all have a particular focus or theme, like such as perimeter or number and train. But this last one here is actually a skill builder lesson, and it has all 3 types of word problems. Okay. Okay, so here's a perimeter problem from week 26. Okay. So I'm just going to read it here. It says that the perimeter of a rectangle is 144 units. Okay, so right away we know 2 pieces of information. Right? We know that the shape that we want to draw, okay, is a rectangle. Okay, so why don't I have Connie go ahead and help me sketch a rectangle in this space right here. Okay. The other piece of information I know is that the rectangle has a perimeter of 144 units. Okay. By the way, what do we know about the measures of the sides opposite each other in a rectangle? Go ahead and type your in the chat box. The question again is, what do we know about the measures of the sides opposite each other in a rectangle. Yeah, you're correct. So when we are labeling this, we know that whatever the measure here on one side, the opposite side has to be the same, and the same thing goes on the other pair of opposite sides. Okay. Now the second sentence says here that the width is 10 units more than the length. Okay. So it may be an obvious question to you, but I would ask the students, which is longer? You know, is it the width or is it the length? Okay. Do we know? If it says that good. Okay, it is the width. Okay. So if I use, okay. So let's just say that, you know, if this was my sketch, then it is more likely that that this is the shorter side is the length and that the longer side is the width. Okay. Now, if I use the variable L to represent the measure of the length, okay, and I put it in the picture, then what expression can I write to represent the width? Okay, Pat says L plus 10 or 10 plus L. Good. Okay. Now, does anybody want to give me an initial? Let me just, instead of giving you 4 random ones, Pat, would you give me a number for an initial guess for the length of the rectangle? Go ahead and type it in your in the chat box, Pat. What would you like to use? Okay, so Pat is suggesting that we use the length of 15. Shelly, would you please help me record that number here where I'm pointing on the whiteboard? Okay. All right. Any particular reason, Pat, why you chose 15? Was it an educated guess, or was it, you know, just a, you know, nice and friendly number, or? Okay. While we're waiting for Pat to answer, Mark, would you write down actually no, Shelly, I had Shelly do that, sorry. Shelly, would you at the top of here give us type a little reminder to us that the width has to be 10 units more than the length, so that when we're doing our computation we can kind of use that as a reminder. Thank you. Okay. Oh, okay, so Pat said it was the number of the day. Okay, that's good enough for me. Okay, so if the length is 15, then what is 10 more than the length? And Shelly, would you please type that in? Okay. Okay, good. And what I would like to do is, this is fine, this is perfect, but if when we're doing this in the classroom, it might be a good idea to show how we got the 25 here. So we would actually show the intermediate step of, oh, there you go, thank you, that we took the length and then we added 10 to get 25, okay? Just so that the students can see a sort of a pattern here developing, okay? All right, Mark, so what is the perimeter if I know that the length is 15 and the width is 25? And everybody else can join also by typing the answer in the chat box. Okay. Okay. Connie says 80 can some, okay, so Pat is confirming that. Good. Okay. All right, so let's check. Our perimeter for the rectangle is supposed to be 144, as I've highlighted here, okay? But right now what we have is 80. So is the length of the rectangle 15? Is that correct? Too small. Okay, I agree. Okay, so using what we've already guessed before, we guessed 15 before. What would you would you guess a higher number or would you guess a lower number at this point? Okay, Connie says higher. Connie, what would you like to guess next? Okay, Connie wants to guess 40. Okay, so go ahead and Pat, I will have you compute the width. Mark, I will have you compute the perimeter. Okay, and then Shelley, if you will just kind of check everybody's work after they've entered their numbers in here. Okay, and then we will evaluate whether to see whether our guess was too high or too low. Okay. Okay, so now this time when we guessed that the length was 40, it turned out to be too high. It actually turned out to be more than double what we got before. But we, you know, we're just using guess and check right now, you know, and it is okay that it is not the most efficient way at this point. Okay. So Shelley, did everybody's work checked out to be okay? Okay. We're gonna one more guess. Okay. One more guess. So, Mark, what would you like to guess this time? Would you guess a lower number, a higher number for the length? Okay, lower. Maybe 25. Okay. So go ahead and let's check to see if that turns out to be closer. So go ahead and Connie, why don't you do the width? Okay. Pat, you do the perimeter. And then Shelley, if you will do the same, assume the same role again to check to make sure everybody's work is correct. So I just want to make a few comments while everybody is working, is that the layout in your student pages is a little bit different than what you see here. I've actually taken out a few rows in our guess and check table because I wanted to be able to fit everything on the whiteboard. But in the student pages, there's actually a lot more rows for the students to be able to guess, make a few more guesses than here. Okay, and in a moment we're just going to do a little cheat sheet. We're going to do a little cheating to see that we can actually get the right number. Okay. Okay. Now this time turns out that 120 was the perimeter, and it was too small. Okay. But we are getting, so we underestimated again. Okay. So what I like to do is play a, just to make things move faster. Go ahead and type in your chat box what you think. What if you had to guess one? If you had one more guess, what number would you guess? Okay. Okay. Mark says 30. Connie says 30. Okay. Shirley says 31 because 1 plus 1 plus 1 plus 1 equals 4, and the answer ends in a 4. Very observant. I think you get the star for the day, Shelley. But okay, and then yeah, you're all very close. So if we had, if we continue doing this, you would have eventually, found that it is actually what Shelley said. It was 31, and that was a very good observation, Shelley. That you did that. Okay, so now what we do is the idea of having you show the work at each step was that so that the students could generalize here for symbolically that when they see that it's whatever the length they have, add 10. So then here in the last row in my table they would actually put L plus 10. Okay, and Connie, if you would label the rectangle for me. Okay, and then for the perimeter, here, it's already partially filled out. This is kind of like a little scaffolding step here that you won't see later on. But here, because this is one of the first problems, we provide that for the students. So we know that the perimeter is 2L plus 2W. So then here, whatever we have for the length, which is L, we would fill it in, and then the width, which is just L plus 10. Okay, it has to be equal to 144. Okay. One word of caution here is that the students may forget to distribute the L plus 10, and they might just put 2 times L and forget that they have to multiply 2 times the 10. So if they forget that, then you can kind of remind them to think back that it's 2 groups of L plus 10. They've seen that in the pizza place lesson earlier in the program. Okay, so then after that, what they would do is write the equation and then solve the equation. And then answer the question, which is how long the length and the width. And then finally, they would check the answer by taking whatever number they got for the length and then whatever number they got for the length and then plug it in back to the equation. And they can also come back here and plug them in here in the picture. Okay, and they would have to apply it to both both sets of opposite sides to get their perimeter. Okay, so any questions? No questions? Okay, real quick, this is a teacher teaching tip from week 26. This really just provides a rationale for using the guess and check tables as a transitional step from numerical to the algebraic strategy. Just be sure that you stress the importance of writing the arithmetic clearly for each step and use it to transition to the symbolic equation, okay, representation. Okay, here's another one, and I thought that it would take a little too long to go through all these problems, so I kind of already got you guys started here. So we have another perimeter problem. This time we have a triangle. It says that the length of the second side of the triangle is twice the length of the first side. Okay, now this sentence gives me 2 pieces of information. First, I need to sketch a rectangle, which I already did here. Okay, and 2, that the length of the second side is double the length of the first side. So I can add that piece of information up here at the top, Shelley. Okay. So if I want to use the variable L again to represent the first side of the triangle, then what expression can I write to represent the second side if I know that it's twice the length of the first side? Good, 2L, okay? Or double, added twice, whatever. Okay, next sentence says that the length of the third side is 4 units more than the first side. Again, I'm going to ask you, which side is longer? It probably is obvious to you, but for English learners, it may not be. I remember having a hard time before solving problems, not knowing really what it meant. But so I'm going to ask you, so does this mean that the third side is longer, or the second, or the first side is longer? Okay, the third side is longer. Okay. And again, if I use the variable L to represent the first side, then what expression can I write to represent the third side? Good, L plus 4, okay? Now, the perimeter finally says that the perimeter is 72 units. So what do the 3 sides of the triangle have to add up to? Right here, what do we have to make sure they add up to? 72. Okay. Oh, I like whoever's doing the highlighting with the color coding. Yeah, I thought that color coding might be a helpful thing to use with the students, and this might be something you might try in the classroom. See, I don't know. Do you like it? Do you have any? Well, I won't ask you for opinion right now because we're short of time. Now, do you think that 20 units was a reasonable initial guess for the length of the first side? It really doesn't matter what students want to guess as the first one. You just want to make sure that you ask them to justify why they pick that, just so that they're not randomly guessing, you know, something that's outrageous. Yeah, so any guess is okay, but I really would like to encourage the students to use some kind of, to be able to justify, you know, like for example, they might say 20. Okay, well, you know, the triangle is, the perimeter is 72 units, and so, you know, 20 is not too far off if each side was distributed evenly, you know. So that was why I put the 20 there. Okay, so it turned out that it was not the correct measure for the first side. Do we need to get something higher or lower? Yeah, and I thought about the 72 divided by 3 as a good starting guess. Or, you know, once you divide and it turned out to be not a friendly number, pick a friendly number that's close to the result of dividing by 3, okay? All right, so what do we want to, oh, so okay, everybody said to guess something lower, okay? Connie, what would you like to guess for the length of the first side? 15? Okay. All right. Mark, go ahead and fill in the second column. Pat, fill in the third column, which is finding the length of the third side. Okay. And then Shelley, if you can find the perimeter. I think the point of using the guess and check, and it's okay that they are not, you know, they don't hit it like in the first few tries. This really provides an impetus for wanting to use the algebraic method, because it is more efficient than having to guess, okay, well now it turned out to be too high, well now it turned out to be too low, and then I have to adjust, oh, I missed it just a little bit more, I have to try it again. So it is, they can see that it is doable, but it is a little cumbersome. So that encourages them to want to use an algebraic approach to solve these problems. Yeah. And yet they have the guess and check table to rely on if they're not completely comfortable with the algebraic method. Okay. All right. So if it turned out to be too low, okay, and we're not going to actually find the exact answer, but type in the chat box. If you had to guess one more time, what would you guess to be the length? We guessed 20. That was too high. We guessed 15. That was too low. So if you had one more shot, what would you think? Okay, Mark now says 15. 17. Sorry. Okay, Shelley says 18. Pat says 18. Yeah, you guys are all very close. It actually turns out that the first side is 17. The length of the first side is 17. So very good. Okay, and then again we would finish up the problem by generalizing. Okay, and then writing the equation and solving it algebraically, and then go back to answer the question. The question is, how long is each side? So we better make sure that we have 3 parts to our answer. For the first length of the first side, second side, and the third side. And then double check by putting them all in, either in the picture or in the equation, to make sure that it adds up to 72. Okay? All right. Oh, I am taking way too long to do these. I apologize. Okay, so now we move into the train problems in lesson 28.2. These are traditionally challenging, but really making a sketch helps the students visualize the situation better. And I've made the sketch here. Really the key is making the right picture, okay? Here we said that the two trains are 360 miles apart, are approaching each other. So what I've done is I've made 2 arrows that are pointing to one another, okay, to show that the trains are approaching. And then right below each train, I've included the rate. So train A was 50 miles per hour, and then B was 40 miles per hour. And I also know from the first sentence that they are 360 miles apart. Okay, so all the information that I have is in this picture right here. Okay, and the question that I'm trying to answer is how far does each train travel? Okay, and how long it will take the trains to meet. Okay, so what we're guessing here is the number of hours. Okay, let me ask you this, and you type your answer in the chat box real quick. If train A is going 50 miles per hour and train B is going 40 miles per hour, well, how long did they travel altogether after 1 hour? Right. So is 1 hour a reasonable number? No. Okay. So yeah, it's too small. Okay. What about after 2 hours? Do you think that would be enough? Okay. And then, you know, so this one actually they can, I suppose they can systematically just go down and increase the number of hours. The numbers are friendly enough where they can just, you know, guess and fill in the table. So turns out here, I think you will probably agree with me that because they're 360 miles apart, it would take them 4 hours. Is that clear? It's a very convoluted problem, but yet when we have the picture, it makes everything just much clearer. Do you see that? Do you agree? Okay, I see a lot of happy faces, so, which is good, okay? All right, the next problem, well, I only have 3 minutes, so I'm going to skip this one, but again, the key is in making the pictures. This one I do want to point out, because if you compare this one, notice how every column is filled in. So you know what you have to enter in each of the columns. But then when you get to problem number 5, train problem number 5 in week 28, all these headers are blank now. Okay, so it's becoming a little bit more challenging for the students, and that's what I want to focus on right now. Is you know, what should the headers be for these columns? Because it is important to know what you want to write here. That would be helpful. Okay, so 2 trains that are 50 miles apart are traveling in opposite directions. So they're 50 miles apart, sandwiched in between the 2 trains. Okay, train I travels at 48 miles per hour. Train J travels at 52 miles per hour. Okay, and how long would it take them to be 650 miles apart? One tricky thing though is you can't, so after 1 hour, you cannot just add the 48 miles and 52 miles, because you have to remember the 50 miles that they were already apart. Okay, so that is something that, you know, that having the picture would help. Okay, that they have to account for this initial 50 miles. Okay. All right. So, so the question is, how many hours would it be until the trains are 650 miles apart? So, what is the number? What variable are we trying to guess here? Yeah, exactly. The number of hours. It is the number of hours. So, Shelley, would you write down number of hours or just hours? Okay. And then what else would be useful to keep track of in the rest of these columns? Okay, the distance that train I travels. So the distance that train I travels would be a good thing to know. So if we keep track of train I, it makes sense for us to keep track of train J. Agree? Okay. And then the last, or the 4th column, sorry, is we have to count up how many total miles apart the 2 trains are, right? But again, what is the one thing we should not forget about? Oh, okay, Joe. Hey, Joe. Okay. Yeah, to add the 50. Exactly. So make sure that when the students are doing, that they are adding the 2nd column, the 3rd column, and the 50 right here to get the total number of miles that the 2 trains are apart. Okay. So so yeah. So do you have any questions? Sorry, we kind of ran out of time. Yeah, so Mark is asking, doesn't the total miles include 50? You mean the 650 includes the 50? That would be correct. The 650 would include the 50 miles, but the amount of distance that the train, each train travels, would not include the 50. That's something that you would have to add on. Like look at Connie's statement in the chat box. Oh, okay, like Connie says, yes. Okay. Okay. Any other questions? No questions? Okay. Well, thank you very much for staying on for the session, and I hopefully the other room is open now, so you can log in if you want to join us for the next session. Okay. I will see you in at 3:45. Okay. Bye.